Welcome back. We're going to introduce video 4 for Unit 12, and this will wrap our discussion about descriptive statistics. The emphasis here is on the idea of a normal curve or a bell curve, and your author refers it to as a normal distribution. And we're not going to create z-scores. We're not going to calculate z-values like some of you may have done if you took a statistics class previous to this. We're going to instead focus on what percentage of the scores fall within a certain number of standard deviations of the mean. We're going to call that the empirical rule. And on this very next slide, you'll see that according to the empirical rule, 68%, roughly 68% of the data points will fall within one standard deviation of the mean. If you go out another standard deviation so that you're now 2 above the mean compared with 2 below the mean, about 95% of the data scores fall within 2 standard deviations of the mean. If you're willing to go one more and you're willing to go 3 standard deviations above the mean and accompanying 3 standard deviations below the mean, then basically you're looking at dang near all of the data falls within 3 standard deviations of the mean. According to your author, 99.7% of the data falls within 3 standard deviations of the mean. So I thought it might be good for us to take a look at a little slide presentation. So let's just go from that slide. All right, so what we're going to do, we're going to find the mean first. That shouldn't shock you because without mean, we can't calculate standard deviation. So for those of you who are pictorial kind of learners, here's a nice image for you. Smack dab in the middle of this is the mean. So straight where you see the peak on that hill, that's the mean. So now visualize, if you will, pulling one standard deviation to the left of that, one standard deviation to the right of that, and you see that we are showing 68% of the data falling within those two numbers. 34% roughly within one standard deviation above the mean, and 34% within one standard deviation below the mean, for a total of 68% within one above and one below. If you pull out 2 standard deviations, you pick up now 95% of the data. And again, if you say, well, what about that little tail up there between 1 standard deviation above and 2 standard deviations above? It's about 13.5. So about 13.5% of your data set falls between 1 standard deviation above the mean and 2 standard deviations above the mean. What you're really doing is you're tracking areas relative to percentages and what you may have known as z-scores. A z-score of 1 would be 1 standard deviation above the mean. If we were to look at that in this context, we could figure out what percentage of the scores are above that. And that would be consisting of the 13.5 point and the 2.35 added together. So about roughly 16% of the data scores above that. All right. All we're going to do is play these numbers. So the problems are a little bit contrived in that you're going to be handed the mean and you're going to be handed the standard deviation. So in this context, we've got Foersters Inc. They manufacture whiteboard markers. The mean life purpose for this in terms of useful markers, 5 days. Calculated standard deviation of 1.2. So the problem says calculate the useful life of the markers that fall within 1 standard deviation of the mean. And it's just arithmetic. So the high edge is 1 standard deviation added to 5. The low edge is 1 standard deviation or 1.2 subtracted from 5. All right, so we would say that between, in this context, 3.8 days and 6.2 days. And what we know from previous slides is that we have an estimated percentage of markers whose length of life would be somewhere between 3.8 days and 6.2 days. And that was, what was it, 68%, I believe? Yep, 68%. So in the problem that we're looking at, we would make the claim that roughly 68% of our markers last between 3.8 days and 6.2 days. If you open another standard deviation above and below the mean, again, it's just arithmetic. So in this context, it's 5 plus and minus 2 times the 1.2. It shouldn't shock you that now you're going to expect an even higher percentage of your markers to fall between these two data points. And if your memory serves, it was 95% of the markers would last somewhere between 2.6 days and 7.4 days. Last but not least, and if you say, well, I want to go 3 standard deviations, well, man, now you're tracking darn near our entire marker population. All right, so as 99.8% of our markers will fall within 3 standard deviations of the mean. And that's the same package of arithmetic. It's you and me and your calculator. So anywhere between 1.4 days and 8.6 days, we're making the claim that roughly 99% of our markers fall between 1.4 days and 8.6 days in terms of life expectancy or practical usefulness. Okay? All right, I threw this one in because I thought it was fun. The problem says calculate the percentage of markers that will last longer than 6.2 days. All right, if you remember, the standard deviation was 5. I'm sorry, the standard deviation is 1.2 and the mean is 5. So 6.2 is a value that's exactly 1 standard deviation above the mean. So if you're tracking that on the little picture out here, you and I in effect are saying what percentage of the markers last longer are values that are greater than 6.2. And that's the right side tail of this curve. It looks like the areas that are included would be 13.5% in addition to 2.35%. So there's your 5, that's the mean. And there's 6.2, that reflects 1 standard deviation above. So we're looking at for that right side tail area. All right. And what I chose to do here was realize that to the right of 5 is exactly half the curve. All right. Again, that's an old statistics trick. 50% above the mean, 50% below the mean. So if you're specifically tracking how much is on that extreme right edge, you're going to take 0.5 or 50% and subtract the 34 because 34% is the area between 5 and 6.2. And you get 16%. So that's roughly what we're going to get if we added the 2 right side percentages. I like it. It's useful. It's a practical application of normal distributions. Some of you, as I've said, probably have done it before. We're not going to get too crazy. We're not going to find any other z-scores other than the z's that will correlate to 1, 2, 3, -1, -2, -3, where you're simply tracking how many standard deviations that number is above or below the mean. So about 16% of the markers will last somewhere longer than 6.2 days. Congrats, we have reached the end of Unit 12. Found some textbook problems for you to practice on. There will be some cool Excel stuff to wrap out the activities for this unit. And you're going to try some problems, send me some solutions. I'll get you some points. As before, questions, I'm only an email away. All right, send me something if you're concerned, and we'll find a way to help get you over the concerns. So thank you very much for watching this video presentation, and we're going to wrap up Unit 12 right here. See ya.